So write the natural log of 2x plus 1 over 2x minus 1 as the difference of two logarithms. This is just a straight log law. It's very straightforward. We've just got to do log 2x plus 1, take away log 2x minus 1. A curve has equation y equals log 2x plus 1 over 2x minus 1 plus 4x for values of x greater than a half. Using your answer to part 1, show that dy dx can be written like this. Okay, so y is the natural log of 2x plus 1. Take away the natural log of 2x minus 1 plus 4x. So dy dx, now think about how log differentiates. It's going to be 1 over 2x plus 1. But then using the chain rule, we have to multiply by the differential of the inside. Take away 1 over 2x minus 1. But then once again, multiply by the differential of the inside. And then that's going to be plus 4. So tidying that, we've got 2 over 2x plus 1. Take away 2 over 2x minus 1 plus 4. And let's get all of that over a common denominator. And that common denominator would be 2x plus 1, 2x minus 1. And so this 2 needs to be multiplied by 2x minus 1. This 2 needs to be multiplied by 2x plus 1. And the 4 needs to be multiplied by both things. Like so. Now the nice thing is that the denominator is going to give us exactly what we've got there. So 4x squared take 1. It's just a difference of perfect squares, so we should be able to write that straight down. And then we have 4x minus 2. Take away 4x, take away 2, plus 4 lots of 4x squared take 1. So the 4x's will cancel there. I've got negative 4 plus 16x squared take away 4 all over 4x squared take 1, which is 16x squared minus 8 over 4x squared minus 1, which is of the right form, with a being equal to 16 and b being equal to negative 8. Okay, continuing on. Find the x-coordinate of the stationary point on the curve. So we need dy dx to be equal to 0 for a stationary point, and that just means the numerator needs to be 0. So we've got 16x squared minus 8 equals 0. 16x squared equals 8. X squared equals half. And that means x would be equal to 1 over root 2. Now it could be plus or minus 1 over root 2. But up here, we said it was just x is greater than a half. And determine the nature of the stationary point. So we need the second differential. Now we know dy dx is 16x squared minus 8 over 4x squared minus 1. Let me just check that that's the case. Yes, that's the case. So we need to differentiate this again, and it's a quotient. So u is 16x squared minus 8, and v is 4x squared minus 1. And I'm beginning to wonder if this is the best way of doing this. It's only 2 marks. Well, let's just go for it. du dx is 32x, and dv dx is 8x. So d2y dx squared is v du dx, so that's 32x, 4x squared, take away 1, take away u dv dx, which is 8x, 16x squared minus 8. and that's all over 4x squared take 1 squared. And we want d2y dx squared given that x is equal to 1 over root 2. And we don't actually need the value. I mean, we could work it out. We've got a calculator. We only need to know whether it's positive or negative. Now, the 1 over root 2 is a solution to 16x squared minus 8 equals 0. So that second part of the d2y dx squared, basically the whole of this is going to turn out to be 0 because of the 16x squared minus 8. So we've got 32 times 1 over root 2 into, so x squared is going to be a half, so that's going to be 2 take away 1 over 2 take away 1 squared. And we can see straight away, we don't need to work this out, we can see that that's positive, and that implies that we have a local minimum. Min-e-mum.